The future of aviation is taking off in a bold new direction, one powered by electric motors that promise to revolutionize flight. As electric propulsion systems push the boundaries of power and efficiency, the race is on to build the next-generation aircraft engine. But will these high-powered electric motors really be the key to sustainable, high-speed flight? Let's dive into the innovations shaping the skies of tomorrow. The race to build high-power density electric motors for aircraft. The aviation industry is rapidly evolving as companies race to develop high-power density electric motors for aircraft. These motors are essential for making electric flight feasible, whether for small electric vertical takeoff and landing aircraft, hybrid propulsion systems, or eventually larger commercial jets. The challenge lies in creating motors that provide enough power while keeping weight low. Companies like Electric and A3X are leading the way with high-performance motors. For example, Electric has developed a 2.5 megawatt motor delivering 16 kilowatt per kilogram, while H3X has a 1.5 megawatt motor weighing 130 kilogram, 300 pound. While these figures represent peak power, continuous output is typically lower. Nevertheless, these innovations could significantly improve the efficiency and viability of electric and hybrid aircraft. The ongoing development of high-power density electric motors is crucial for the future of sustainable aviation. The power density challenge and scaling up for larger aircraft. A major challenge for electric propulsion in large aircraft is the energy density gap between batteries and jet fuel. Current batteries provide about 25 times less energy per kilogram than jet fuel, making scalability an issue for larger aircraft. The energy required to power bigger aircraft engines increases exponentially with size. Additionally, batteries must support long-duration flights, but unlike jet fuel, battery weight remains constant throughout the flight, hindering efficiency. While electric propulsion may be feasible for small aircraft or short-range vehicles, it remains a significant challenge for large commercial jets. Until battery technology improves, electric aircraft will be limited in both range and payload capacity. The efficiency advantage of electric motors. While batteries present a significant limitation, electric motors themselves offer distinct efficiency advantages over traditional jet engines, particularly during specific phases of flight. Electric motors are far more efficient than conventional turbojet or turbofan engines, especially during steady-state conditions such as cruising or taxiing. Modern jet engines, such as turbofans, are optimized for high-speed flight and involve complex mechanical systems that control the flow of air into the engine and manage the compression ratios. This often results in inefficiencies, especially at lower speeds or during ground operations. Electric motors, by contrast, can provide nearly instantaneous torque and operate more efficiently at lower speeds. This makes them ideal for improving efficiency during phases of flight like taxiing, low-speed cruise, or takeoff. Consequently, the ability to integrate electric motors into jet engines or aircraft propulsion systems offers significant benefits, particularly when combined with hybrid powertrains that use both electric and traditional combustion engines. Incorporating electric motors into jet engines. Several projects are exploring the integration of electric motors into jet engines to boost efficiency. One approach is using an electric motor to control the compressor, optimizing air intake and fuel consumption. By adding electrical control, the airflow can be adjusted in real time, improving fuel efficiency and reducing waste. The electric motor could spin the compressor independently of the combustion engine, enhancing efficiency at various flight stages. This system could also improve transitions between flight modes, like takeoff to cruise or descent. While the potential efficiency gains are significant, this technology is still in the research and development phase and requires further testing and optimization. The turbo generator concept, a potential game changer for supersonic flight. The turbo generator is an innovative concept in electric propulsion, consisting of a small turbine connected to a generator to provide electrical power without the need for heavy batteries. Integrated into the aircraft's propulsion system, it can power auxiliary systems or even the compressor in a hybrid setup. This technology could enhance the efficiency of supersonic aircraft by reducing battery weight while still benefiting from electric propulsion's advantages. It allows for power generation during flight, enabling longer and faster supersonic flights. The turbo generator runs on the same fuel as the jet engine, eliminating the need for specialized fuels and maintaining traditional fueling infrastructure. How turbo generators could improve supersonic flight efficiency. The integration of a turbo generator into supersonic flight presents the possibility of significantly increasing the range of supersonic aircraft like the Concorde. Research suggests that the efficiency improvements enabled by a turbo generator could boost the range of supersonic aircraft by up to 61%, a substantial increase that could make supersonic commercial flight more viable. Supersonic flight has long been limited by its high fuel consumption and associated environmental impacts. By using a hybrid propulsion system with a turbo generator, the overall fuel efficiency can be increased, while still achieving the high speeds required for supersonic flight. This also opens up new possibilities for using alternative fuels like LNG or synthetic methane, which could further reduce the environmental footprint of supersonic air travel. However, this technology does raise questions about the size and power output of the turbo generator required to achieve these benefits. It will take time to determine how this system can be scaled effectively for commercial applications. The sonic boom problem and supersonic aircraft design. One of the major challenges facing supersonic flight, especially over populated areas, is the sonic boom. The shockwave produced by aircraft flying faster than the speed of sound creates a loud, disruptive noise that can be heard miles away. This has been a significant barrier to widespread supersonic travel since the Concorde era. To overcome this challenge, new supersonic aircraft designs are focused on mitigating or controlling the sonic boom. The integration of turbo generators and other hybrid propulsion technologies might offer a path forward. Hybrid systems could potentially reduce the intensity of the shockwave, making supersonic flight more acceptable for commercial aviation in populated regions. The technology also holds the promise of making supersonic travel more efficient and sustainable, as hybrid and turbo-electric systems could help reduce the environmental impacts that were traditionally associated with supersonic flight. Hybrid propulsion for electric vertical takeoff and landing aircraft. Hybrid electric propulsion is gaining attention not only for large aircraft, but also for smaller electric vertical takeoff and landing aircraft. These aircraft, designed to take off and land vertically like helicopters, could benefit from systems combining electric motors and traditional engines. A promising example is the Vertical Aerospace VH4, a hybrid vertical takeoff and landing with a medium bypass turbofan engine for cruising. This engine can switch to function as a power generator when vertical thrust isn't needed, allowing the aircraft to seamlessly transition between vertical takeoff and cruising modes. This hybrid approach enhances energy efficiency and speed, making vertical takeoff and landings more viable for urban air mobility, where both maneuverability and efficiency are crucial. Emerging technologies for electric aircraft. A look at prototypes. Several companies are already developing prototypes of electric aircraft that could serve as models for the future of aviation. One such prototype is the CET-X5, a hybrid aircraft that is capable of vertical takeoff and landing. It is equipped with electric motors for low-speed maneuvering and a pusher prop for high-speed flight. This combination of electric motors and traditional propulsion is designed to maximize aerodynamic efficiency while providing a hybrid powertrain that can operate in a variety of conditions. The electric motors on the CET-X5 are powered by batteries, but the aircraft also features an advanced energy management system that optimizes the use of both electric power and combustion-based engines. That's all for today's video. If you found these innovations in electric aviation fascinating, make sure to hit that like button and share your thoughts in the comments. Don't forget to subscribe for more updates on the cutting-edge technologies transforming the future of flight. Stay tuned, the skies are changing.